These are the frequently asked questions for Algebra 2 for Section 4.6, Day 1. Starting with number 22, we have x squared plus 8x plus 16 equals 16/9. And what we don't want to do is move that 16/9 over. For obvious reasons, that's going to mess up our C value big time. So hopefully we notice that this is a perfect square in the front and this is a perfect square in the back. And then we check that middle term by taking what we would have squared for A and C there, the x and the 4, multiplying them together and doubling it. So 4 times x is 4x, times 2 is 8x. That tells us we do have a perfect square trinomial, which means this was really x plus 4, the quantity squared, equals 16/9. And now we have this set up very nicely to just take the square root of both sides, and square root and squaring are inverses of each other. So on the left-hand side, we're just going to get x plus 4. But the key is remembering whenever we physically write down that square root symbol to solve, we have to put plus or minus. So square root of 16/9, well, square root of 16 is 4, and the square root of 9 is 3. So x plus 4 equals plus or minus 4/3. And then we'd have to go ahead and subtract 4 from both sides. So x equals -4 plus and minus 4/3. And we can actually get that answer, so we have to. We have to find the answers whenever we can. So what I'm going to do is I'm going to change that -4/1 into a common denominator of 3 by multiplying the top and the bottom by 3. And you'll see right there, -12 divided by 3 would give you -4, plus or minus 4/3. So now we just continue on and actually find those two answers. The first one is -12/3 plus 4/3, and that will be a -8/3. And the second one would be -12/3 minus 4/3, which would be a -16/3. So we're just separating this into the two statements that it really is. And getting those answers. And it doesn't matter which one you do first. I just happened to do the addition one first before I did the subtraction one, so it doesn't make any difference which one of those comes first. But we have both the answers, and again, they're checkable. If we put them back up into the original equation, they're going to make that equation work. Now, the next one would be number 25. All right, and again, you'd start by saying, wow, 25 is a pretty big number. Maybe I can pull out a common monomial factor. But then you realize you don't want to, because that's 5x squared. That's 1 squared. And when you multiply them together and then double them, you do get 10x in the middle. So this is really 5x plus 1, the quantity squared equals 9. And again, we want to take advantage of that and realize, hey, we can just take the square root of both sides and get 5x plus 1 equals plus or minus 3, because when we write that square root, we need the plus or minus. Then we'd subtract 1 from both sides, and then we would divide by 5. And again, we do need to continue on and actually find those two answers. So we would do -1 plus 3, which would give us 2/5. And then -1 minus 3, which would be a -4/5. So just continuing on and finding those solutions. And I will need to erase here so that I can do the other two problems that I have up here as frequently asked questions. Number 26. All right, large numbers, but again, I notice we have a perfect square in the front and we have a perfect square in the back. Multiply those together, double them, and you do get the 30 in the middle, but this time it's a -30. So it's going to be the quantity x minus 15 squared equals 400. And then we would go ahead and take the square root of both sides. So x minus 15 equals plus or minus 20. The square root of 400 is 20 there. And then we'd have to add 15 to both sides, so 15 plus or minus 20. And 15 plus 20 is 35. And 15 minus 20 is a negative 5. So those are our two solutions for number 26. Number 27, 9x squared plus 24x plus 16 equals 36. Again, large numbers, but we notice in the front, this is a perfect square, and in the back, this is a perfect square. 3x times 4 is 12x, and when you double it, you do get 24. And this one had all addition in there, so it will be 3x plus 4, the quantity squared, equals 36. Then what we need to do is take the square root of both sides, and 3x plus 4 will equal plus and minus 6. And then we go ahead and do the algebra, so 3x will equal negative 4 plus or minus 6, and divide by 3, negative 4 plus or minus 6 divided by 3, and continue on and find those two solutions. So we have a negative 4 plus 6, which is 2, so we'll have 2/3 for one of the solutions. Negative 4 minus 6 is negative 10, so negative 10/3 for the second solution. And I believe those were the frequently asked questions on this page, but at the end I thought just maybe, it's been a while since we talked about some of these topics. So number 90, we're going to solve that by factoring. And this is one of those problems where we don't have a common monomial factor. It's not a perfect square. And we have to do those combinations of numbers in the front that multiply to 2. And in the back, they would have to multiply to 1, but add to a negative 3. So that means they both have to be negative. That's the only way that that's going to happen. And in this case, it doesn't make any difference which one of these two in the front that we pick. Outside times outside will be negative 1, and inside times inside will be negative 2 in this situation. So these are my front pairs here, x and 2x. And these are the last pairs here, negative 1, negative 1. And so one of my zeros is just going to be x equals 1. And then this one, if you need to, go ahead and set it up so you realize I'm going to add 1 and divide by 2. So x equals 1/2. So solving by factoring, we factor and then we find the zeros. Finding the zeros, finding the x-intercepts is solving. Then number 96, this one is solving by elimination. And elimination is when we add the two together, hoping that something's going to drop out, or we have to make something drop out. In this case, the positive y and the negative y are already set up to drop out, so we would just add these together and get 5x equals 10, divide by 5, and we have x equals 2. But now we need to put that back up into one of the original equations. I'm going to use the 2x plus y equals 4 here. And that will give me 4 plus y equals 4. You subtract 4 from both sides, and you get a 0 for y. So ordered pair there of 2, 0, and you try that out in both of those equations, and it works. Those are the frequently asked questions for section 4-6.